This presentation shows how the approach of the TERESA project facilitates the reuse of security and dependability patterns. It is demonstrated by the railways use case. We will now illustrate the TERESA approach in a railways use case. Railways manufacturers develop products such as traction systems, control unit systems, and railway signaling systems. Many of these systems need to meet safety-related requirements and consequently to meet related standards. The IEC 61508 standard is intended to be a basic functional safety standard applicable to all kinds of industry. The EN 50128 standard provides a specific interpretation of IEC 61508 for software for railway control and protection systems of railways applications. Let us assume that a train subsystem manufacturer, which we will call Company A, wishes to provide a function to supervise a train's traveling distance and speed. The function has strong safety requirements. In the EN 50128 safety-related standard, it must meet a level of safety called SIL 4. SIL stands for Safety Integrity Level. SIL 4 means that the probability of dangerous failure per hour is extremely low. The company uses the TERESA repository to integrate S&D patterns that have been developed in the past and stored. Company knowledge and expertise in that area is therefore stored in a structured manner. In order to develop such functions, Company A uses a development process which meets safety-related requirements. It includes a number of phases which are the System Concept Specification phase, the System Architecture Design phase, the Module Detailed Design phase, the Implementation phase, the Module Testing phase, including verification with the Module Detailed Design, the Integration Testing phase, including verification with the System Architecture Design, and the Validation phase, including validation with the System Concept Specification. Company A is building a system based on the Triple Modular Redundancy Architecture, or TMR. In this approach, 3 nodes are used. These nodes communicate through a standard Ethernet network. Company A wants to include a feature called Safety Communication Layer, which provides a safety layer that allows the 3 nodes to communicate in a dependable manner. This layer guarantees that the shared data are correct and that they are sent to the right destination in time. Instead of repeatedly developing the widely used Safety Communication Layer feature, TERESA offers a repository to reuse an S&D pattern that was previously developed and stored. Company A's knowledge and expertise in the Safety Communication Layer is therefore stored in a structured manner. The pattern engineer is in charge of developing the patterns such as the Safety Communication Layer. He creates the patterns and stores the artifacts in a repository using the pattern editing tools. The railway application engineer develops the application in such a way that patterns can be reused. The pattern integrator uses the pattern instantiation tools to import artifacts from the repository for the use in process engineering tools. TERESA assumes that there is a separation of roles among engineers. The objective of the pattern engineer is to create reusable subsystems. He develops patterns for security and dependability using pattern editing tools. They allow for the creation and storage of engineering artifacts, which are the blue balls in the picture. The objective of a pattern integrator is to ensure that the patterns can be used in the development of applications in a given domain. She uses pattern instantiation tools which transform the repository artifacts in a form that is adapted to the application development environment, which are the red balls in the picture. The railway application engineer developing the application at Company A uses the following tools. DOORS, which is a widely used tool to express requirements. Rhapsody, which is a widely used tool developed by IBM to allow for model-driven engineering. It supports the SysML and UML languages. And the Visual Studio C development environment. In addition, the pattern integrator uses the pattern instantiation tools specifically built for the company. The pattern integrator uses the repository access tools as follows. First, she searches for the safety communication layer pattern in the TERESA access tool. Then she imports the pattern. All the stored artifacts in the TERESA repository are transformed into Rhapsody artifacts. And finally, she integrates the models related to the safety communication layer into the design of the TMR system. The railway application engineer has to provide a system concept diagram with the Rhapsody tool. He has interacted with the pattern integrator because he wants to reuse the safety communication layer pattern. The pattern integrator provides the pattern artifacts of the safety communication layer in Rhapsody format. She uses the pattern instantiating tool to extract and import the artifacts. The railway application engineer provides a Rhapsody system concept diagram which uses the pattern. This approach is replicated in each phase of the process where patterns can be involved, from the system concept specification to the validation of the resulting product. There are a number of benefits that the tools and methods of the TERESA project provide to the railways domain. The company knowledge is conveniently stored and reused. The process is enhanced, thus reducing the probability of systematic faults. The cost and time to market are significantly reduced. And the required number of safety engineers is reduced. The use case described in this presentation is based on existing work done by Ikerlan. The tools mentioned in the example, DOORS, Rhapsody, and Visual Studio, are used by Ikerlan engineers. TERESA stands for Trusted Computing Engineering for Resource-Constrained Embedded Systems Applications. TERESA is a project supported by the 7th Framework Program of the European Commission.